Welcome back. In this clip, we're going to create nParticles with emitter type as a directional. So let's go inside the nParticles menu and click the Create Emitter. Let's go inside the option box and make sure we are working with the emitter type as a directional. Create this. Now select the emitter node and reposition this. So without any other changes inside any of the node, let's play the timeline and notice the default behavior of the particles. So as we all know that these particles are still under the impact of the gravity. So select the particles, press Ctrl A and move inside the dynamic properties and click the option Ignore Solver Gravity. Now roll back the timeline and now you'll see these particles are creating a kind of a line. So let's examine the reason that first of all why these particles are moving towards the x positive axis. Well, under the emitter node, if you go inside the distance and direction attributes, you'll notice we have the direction x set to the 1. Now this 1 is the indication of x positive. What if we have the -1? So with this, the particle will move in the opposite directions, that is the x negative. Alright, let's change this direction to 0 and use the direction y as a y positive. So as a result of this, the particles will move towards the y positive axis. Let's bring some more change inside the speed and random speed as well. Okay, and now if I play the timeline, you notice these particles are moving fast, but they are still creating a kind of a line, and no doubt this line is getting break from several points, but still it's a kind of a line. So how are we going to bring some more depth inside the motion of the particles? Well, we can achieve this with the help of an attribute, that is the spread. So this attribute will actually going to make the particle spread, and let's use this. Let's use the value 0.1, and now let's play the timeline. So with this, you can see these particles are now actually getting spread, and as far as these are moving away from the point of the emissions, the more they are spreading. Alright, let's also increase the rate of the particles. So with the default value of 100, let's extend this to 500. And now if you play the timeline, you can notice that with the existing settings of particles, these particles are actually moving way long towards the y positive axis, and seems to be like they are kind of a never-ending particles, because presently we don't have any settings with respect to the age. Or what if we want to make the particle die out? So how are we going to achieve this? Well, we need to select the particles, and inside the nParticle shape node we have the lifespan mode. Let's change this value from live forever to a constant. Now this attribute will going to work upon the time. So 1 is representing 1 second, and technically 1 is also representing 24 frames. So as far as these particles are under the range of 0 to 24 frames, these particles will continue to live, but the moment they cross 24th frame, they will instantly die. And now you can notice if I play the timeline, these particles are now not able to make them extend, because now the life has been decreased, so none of the particles can able to exist beyond the 24th frame. So what if we need to have some more randomness inside the overall age, and we need to have some more nice subtleties inside the age of the particles? We can achieve this while using the random range. Everything will going to work same, but now we have another option, that is the lifespan random, and this will going to bring some more randomness inside the overall particle age. Let's say we have lifespan mode to 1.5. that means now we have 36 frames, and the particle can exist between the value of 0 to 35 or 36 frames. Let's have the lifespan random to, let's say, 0.5. Now the overall age for the particle will be somewhere around 2 to 1. This 0.5 value will going to act as a plus as well as minus for the lifespan. And now if I roll back the timeline, you'll notice there are some randomness inside the particles age. At least they are not dying instantly. We can also increase this value while increasing the lifespan random. Now let's play the timeline once again, and you notice the particles are now dying slowly and gradually. It's not something like they are dying instantly. Okay, let's do another change, let's change the default type of the particle from point to the sphere. Alright, so to achieve this, we need to go inside the shading, and over here we have the particle render type. So with the default value of points, let's change this thing to the sphere. So this way we can have 3D particles. So for the moment, let's do one thing. Let's reduce the rate from 500 to, let's say, 250, and let's increase the spread from 0.1 to, let's say, 0.25. Let's also increase the speed to, let's say, 12 units and speed random to 5 units. And now let's play the timeline. So notice these particles are now very nicely moving towards y positive axis with random values of the age. Let's also do one thing. Why don't we randomize the overall shape, or you can say overall size of the particles? Let's bring some more changes inside the radius of these spheres. So for that, we need to go inside the nParticle shape node, and over here we have the particle size with an attribute radius. So if I increase the value to 0.5, you can see the particle size have now increased. So let's bring it back to 0.1 again, or maybe 0.15, and let's use this value radius scale to bring some subtleties inside the overall radius of the particles. Let's bring some more randomness inside the radius. So that could be possible if we use the radius scale input, which is at present set to the off. So instead of this, we can use the randomize IDs. And now if I drag this slider, you can notice now these particles are having different sizes. Some of them are really very small, while some of them are getting bigger. We can also play with this graph value. Let's bring it down and let's have some more changes inside this. So with this way, you can also add some nice, variations inside the overall particles. Alright, so let's play the timeline once again, and now you can see we have some very nice variations inside the particles. So let's do one thing. Why don't we have, instead of having this white color particles, why don't we add some nice colors to the particles? So that can be possible. For that, we need to go inside the shading sections, and over here we have a color. So change this value from white default to, let's say, yellow, and we can also add some more colors to it. So add some few more color entry lists and change the values according to your own aesthetic decisions. And let's say we add some red to this, and let's say we add some cyan color to this, finally with the magenta. And notice we have the color input set to the constant. So just like the way we did inside the section of the radius, inside the radius scale, we change this value of radius scale input from off to the randomized ID. In a similar fashion, we can change the color input from constant to the randomized ID. So with that, now we have some nice colors. And let me just bring this yellow over here. Pretty nice. And let's do one thing. Let's get the gravity back. So select the particles, and inside the dynamic properties, let's enable these options. And once you enable this, you'll notice these particles will go a further distance towards the y positive, and then they'll come back because now they are under the impact of the gravity. Let's also increase the age to, let's say, 2.5. But notice these particles are actually falling. What if I just want to see the impact of the particles on the ground, and I want these particles to actually collide with the ground? So instead of taking a polygonal plane or any of the geometry and we make that thing as a collider or as a passive collider, instead of this, we can take the advantage of the nucleus solver. It has its own inbuilt ground plane. This imaginary, not imaginary actually, but an infinite long plane can provide you with the facility upon which you can make your particle collide. And that's something which is really nice. So as if for now, we can actually see the overall behavior of the particles with the random age, random size, random colors. Alright, so that's all for this clip. We'll take a pause over here, and I'd like to begin with the next one